I'd like to show you my new 3D simulator. Now, I'm going to start producing some more polished videos next week. So this is just a little cameo just to show you what I can do with the simulator. So what I'm going to do is simulate the inverse Fourier transform. So you can see here what we have in blue is the function, which is a function of frequency omega. And you can see this is the real part of the function f of j omega. Now we're going to go from the frequency domain to the time domain. And this is the time domain equivalent of that function. So in effect, we've taken this function and we've inverse transformed it to give you the function of time. So we've gone from frequency to time. Now we're going to work through this surface here. So this surface is built up of the omega, which is the frequency axis, and the t, which is the time axis. And the z-axis here is going to be cos omega t, but the cos omega t is also going to be multiplied by this f of j omega. So we're going to take this blue function, and the blue function is going to multiply the cos omega t surface to give us this overall surface that you see here in pink. And then what we're going to do is we're going to integrate this function from this point here to this point here along the omega axis. So you can be able to see that the little blue function here is actually just the same as the blue function here, but it can move along the f of j omega cos omega t surface, and you see that moving along there. And what we do is we work out the area under this blue function at each point, and we take that area and we map it onto the point here in the time domain, and this gives us the time domain equivalent of this sinc function. So let's quickly have a little look at the actual mathematics that we can use to perform this. So we're going to have the Fourier transform, which you see here at the inverse Fourier transform, f of t 1 upon 2 pi integral from minus infinity to infinity over f of j omega times e to j omega t by dt d omega. Now, as I said, the e to the j omega t can be written in this form here. Okay, so it's going to be a cos omega t and sin omega t. So this is where we get our cos omega t surface. But we would also have a sin omega t surface. But in this instance here, what we've got is a simplified version because we've got a purely even function. So that is, the blue function has got a mirror symmetry through this axis. So it means that if we were to put this equation here into this one, we're going to get this equation here. Now, this f of j omega is the blue one, which is an even function. The sine function is an odd function. So whenever you multiply an even function with an odd function, you get an odd function. And when you integrate an odd function from minus infinity to infinity, you get the value of 0. So it means we can get rid of this little section of the inverse transform, the j sin omega t. So we're going to be left in the end with just the Fourier transform as 1 upon 2 pi, the integral from minus infinity to infinity over f of j omega, but we only multiply it by the cos omega t surface. And you see that's what we've done here. We've got the f of j omega times the cos omega t surface, and this is what we get here. And then what we have to do is integrate it with respect to omega. So we've got to integrate it along the omega axis. That is, we've got to find the area on this little blue curve and then plot it in the time axis. And this will give us our Fourier transform of our sinc function. Now, I wanted to show you this just to show you the simulator and to note that it can do pretty much whatever I want it to do now, and I can represent really any types of function in 3 dimensions, and it's going to allow me to generate lots of nice 3D mathematical videos, and that's what I'm going to start doing sometime next week, along with obviously continuing with my Design a CPU 3 course. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.